If that's okay, and then those serve as the description for connection management, connection establishment, and connection closure. And so that these two serving as the connection management. And if you understand this, and that's all, this is a discussion about the connection management. All right, that's it. So up to now, we already know some of details about TCP, RDT, and the TCP flow control, and also TCP connection management. But still, we need to discuss further about congestion control. So next one, we already have the principles first. Principles of congestion control. Well, congestion control. So here, we already have the first idea informally. Too many sources sending too much data, and so that the network cannot handle. All right, and this one, it is called the congestion control. And of course, congestion control different from flow control, because congestion and flow, of course, they are different. And also, we got to know the reason why we will have the congestion control, because too many sources sending too much data to the network, and so that the network cannot handle properly. Because of this, so we should have the congestion control. For the congestion control, how to find we have the congestion control? In the past, we have the word manifest. By this time, we use the noun manifestations. 也就是说，如何呈现这样的一个现象 manifestation. Manifestation, we have two ways to let you know the two possible phenomena. Lost packets, long delays. I think previously you understand we may have an event of lost packets. Lost packet, why we will have a lost packet? Because too much data. So of course we may have an overflow. So first one, and another one, queuing delay, waiting for a long time. Well, maybe you may have a similar phenomena for flow control, but here we use the two events for congestion control. And talking about congestion control, in fact, it's the issue of top 10 problem. All right, so because of this, we want to know congestion control. And later, in fact, we already have some scenarios. And the scenario that you know, yes, we have the different level of congestion. So first of all, we already know we have two senders and two receivers. Two senders here and two receivers. And for the current, here it's the switch, or it's the router. We have the buffer, and only switch router serving as a network. So one router, and we assume we have the infinite size buffer. And for the upper link, we have R here. And no retransmission, it says we have the ideal channel, and so that it's not necessary to have the retransmission. And look at this, if we have a capacity R, and later we can know because of a TCP, so TCP can share the bandwidth. Right now we have two connections, so each one share R over 2. If share R over 2, we can increase the transmission rate until we reach R over 2, and so that this connection reach saturation. Reach saturation, and then it cannot send any more. Actually, it can send data, but cannot exceed the bandwidth. So only reach R/2 for one connection. If we have a situation here, it says normal segments can be sent, so you can check the delay. Because normal segment can be sent, in the previous chapter, we can know when checking this point, what is the delay? The delay has reached infinity. And so that we can have a phenomenon like this. A phenomenon like this, and then we can know long delay. Here, it's a long delay. It is a really long delay and incur quite a long delay, and then we have a congestion. All right, so this is the first one, long delay. So because of this, it's a problem. Well, next one, we have a bit detailed, but we assume finite buffer. Finite buffer says some segment can be dropped, and so that we may resend. So we have the retransmitted data, and so that the real rate can more than the pure rate, and so that can we have the best result. Look at this. We can send, and normally we have this, but this time we cannot have the ideal case like this. We need to send more because of dropping. Because of send more, so when we can reach that one, send more, and so that we can reach. So here, more. Why? More than this, and so that more than the rate required, and so that we can reach that level. All right, so for this, if we have the finite size of the buffer, then we need to send more. So here you can see we have a gap. The gap something like we need to behave maybe harder. Behave harder, send more, and so that we can reach the same level R/2. Well, if we have a non-ideal setting, and then we may have a problem like that. And in fact, you can have the others. We can have a duplicate, and we can have something else. So we may have even worse scenario. Well, if so, and then we may reach that level. All right, so perhaps we may even worse. So here, even worse, then we have a congestion because you try to send more. So send more, and then you have the actual one, and then you can cause the congestion. And in fact, we can make the scenario even more complicated. And so that we have a full send and multi-hop pass, and maybe we have a timeout and retransmission. And we just let you know all of this and how to have the results. It says maybe we have the capacity, but even worse, because many segments same, they can collide together so that the situation becomes even worse, and so that previously we expect to the level. However, no, we reach the level here, but we can drop deeply. Well, because of this, of course, we need to take care of the congestion. So up to now, why we don't have the three scenarios? We just want to let you know, yes, for the complicated network scenario, we may have the problem of congestion. If we want to take care of the congestion problem, and then we need to have some way, and the way here we call congestion.